Hello everyone, I welcome you all to the Advanced Technology News Server. Saudi Krap, Namaskar, and welcome you to this first episode of the Advanced Technology News Server. Through this program, we try to introduce the latest issues, related technologies related to the industry. And today, the session is focusing on the latest trends in hydrogen energy economy. The presentation will be by Mr. Kedar Murthy, who is the Chief Commercial Officer at Nuvera Fuel Cells based in USA. Before I let him to give a talk, let me quickly introduce to you all about Technobis. Technobis is based in Thailand, and it is recognized as International Resource Center for Polymer Processing Industries and also process and manufacturing technologies. And you can find all the information on Technobis at technobis.org. Just give you an overview about what is Technobis, what kind of services we offer. We're specialized in the professional education. We offer training, master classes, both in online as well as in-person programs. We also have publications and other things. We also do various business services. We host exhibitions, conferences, networking events, road shows, and also do consulting and technical and business consulting along with the marketing and branding of the technologies. When it comes to industry and technology focus, we are pretty much onto the polymer industry mainly. Rubber, plastics, polyurethane, adhesive coatings, and also non-polymer size energy, environment, membranes and filtration, recycling, recovery, and also smart manufacturing. The reason we start this advanced technology news server, as you know, the technology changes on a daily basis nowadays, so we want industry to keep updated and look at various opportunities that you can upgrade and utilize these latest technologies through this program. And I do encourage all of you, if you are a user of Line app, please scan this. So you can always connect through this Line app. Okay. As you know, we are based in Thailand, so we use a Line, and we also are available on WhatsApp as well. So that's about it. That's about what is Technobis, and please do check our website, technobis.org. Okay, let's get to today's episode on the Advanced Technology News Server, latest trends in hydrogen economy. Our invite speaker is Mr. Kedar Murthy. He is a Chief Commercial Officer at Nuvera Fuel Cells based in USA. So let's welcome Kedar to make a presentation on the latest trends in hydrogen energy economy.
Good evening and good morning to everybody around the world. Good evening to the people in Thailand. So today, my name is Kedar Murthy, as Param said. Thank you for having me on this call. Today, I'm going to talk about a few things. The first thing is I'm going to give you an introduction to who Nuvera Fuel Cells is. That'll give you an idea of the fuel cell economy around the world and what we do. The second part will be around hydrogen and why hydrogen. Why is it important? I think people are starting to see a lot of hype and a lot of articles about the hydrogen economy. Third part will be about fuel cell technology. So I'll dive into what is a fuel cell, how does it work, the challenges around the technology. And then finally, I'll end up with some closing comments about Nuvera and where the technology is in terms of commercialization. So to start out, Nuvera was founded about 20 years ago in Boston, in North America, where our headquarters is today. And it started out as as you may imagine, a development company that worked for the US government, the Department of Energy and the Department of Defense, developing next generation fuel cell technology. And as you can imagine, if you go back 20 years, very few people were talking about fuel cells. And over the years, Nuvera developed some unique technology that now goes into vehicles being operated on hydrogen. Some of the benefits of what we call a hydrogen fuel cell engine, which is what you see in the picture here, is, it's fast refueling, high efficiency, you can go long distances, and the key point is you can get to zero CO2 emissions, which is what the world is really striving for. The key to really, if you think about a fuel cell engine compared to an IC engine, it's really about reliability. So today you get into your car, be it gasoline or your diesel vehicle, and pretty much 99.9% of the time, it starts up, right? No issues. Fuel cell technology is a bit temperamental, and so the key in the industry is really, can we match the reliability of an IC or a diesel engine? So if you think about hydrogen fuel cell engines, this is what we make today. So think about hydrogen as portable electricity, right? Hydrogen is carried as a fuel, like petroleum and natural gas, and it's used to refuel a fuel cell vehicle in the same amount of time as it takes to refill a diesel vehicle. Compared to batteries, hydrogen has much more energy density, and as a result, electric fuel cell vehicles generally have a greater range than battery vehicles. And what you see here on the right-hand side is what we call the Nuvera fuel cell engine. Fuel cell engines are measured in kilowatts, and this is an example of our 60 kilowatt engine. So think of this as the engine block in your car. So if you took your engine block out, or you built a vehicle with a hydrogen fuel cell engine, you would still have to add the radiator or thermal management. You would still have to add a battery and all the control systems that go with the vehicle. So a bit of history again about Nuvera. Founded almost 22 years ago. We have over 800 patents in fuel cell technology, and we've done a lot of projects over the years. So from the several automotive vehicles to buses to tractors, and today our technology is commercial in forklift trucks around the world. We have a bus that's running in China and one shortly to be running in India. And then we're focused on ports. The reason we're focused on ports is that's where a lot of diesel is used today, and it's a very ripe opportunity to go to zero CO2. Nuvera is a global company. We're part of a $3 billion US company called Hyster-Yale. That's a world leader in material handling, so forklift trucks and equipment that's used in ports. Nuvera is headquartered in Boston, where we have our manufacturing. And then in Europe, we have an engine testing facility near Milan. And then we have application development and technical service in China. And then as part of the Hyster-Yale network, we have a full dealership network that we can leverage around the world to support customers. So I wanted to get into why hydrogen for transportation, right? This is an important thing, right? So hydrogen, right? Hydrogen based fuel cell technology is currently generating significant interest, as we know, across multiple industries. As companies worldwide look to lower carbon footprint of their operations, and in their internal goals and stakeholder demands and regulatory pressures to reduce CO2. In addition, hydrogen is the lightest element and the most abundant chemical substance in the universe. In standard conditions, it's present as a gas of dielectric molecules consisting of two hydrogen atoms and hydrogen, and is highly flammable substance that can be used directly as a fuel, which I'll explain later, to generate electricity in fuel cells. So today, if you look at the world, again, electricity is an energy carrier. Electricity can be made from many diverse feedstocks, from solar to nuclear to hydro to natural gas and coal. Today, electricity is primarily for stationary applications, so for powering our homes and our factories. Electrical power is distributed through a grid to homes and businesses and factories. And many uses such as electronics and other devices that don't require a great deal of power batteries are the practical energy storage device today. But for larger applications like vehicles, long recharge times, low power density makes their use on industrial equipment, trucks, buses, and automobiles limited or impossible. Petroleum is the dominant energy source in our world today for transportation because it's energy dense and it's portable. We all know, and we all have heard stories of the oil embargo, the energy crisis. However, the fossil fuel era is coming to an end. Not only are coal, oil, and natural gas becoming scarcer and more difficult to extract, but their extraction and the use are taking a tremendous toll on the environment. So what are the best clean transportation options emerging now? So in terms of hydrogen, hydrogen is alternative energy, as I had mentioned. And there are various types of hydrogen. If you think about hydrogen today, the most prevalent use of hydrogen is in the refinery industry. So for refined oils, and then also in the steel industry. So when we talk about hydrogen, it's also good to differentiate the various types of hydrogen that industry is working on today. So again, the most prevalent today is what we call gray hydrogen. It comes from the cracking of natural gas. It's called SMR, steam methane reformation, where steam and methane are combined under pressure to generate hydrogen. This releases the greatest amount of CO2 in the world today. And again, 98% of the hydrogen that's produced today used in steel and the refinery industry is produced through steam methane reformation. There's what we call green hydrogen. So green hydrogen is manufactured by what we call electrolysis of water. So electricity and water are combined to generate hydrogen. So getting closer to reducing the amount of CO2, but still the electricity coming from the grid, coal or natural gas generates CO2 along its supply chain. So we can't call that zero. The third method is through steam methane reforming or coal gasification with the CO2 captured and sequestered. We call that blue hydrogen, a complex and a fairly expensive technology. Pink hydrogen, on the other hand, is produced by electrolysis with the electricity generated by nuclear power. Yellow hydrogen is the same, electrolysis produced by using electricity through the grid. And then what we call cyan or turquoise hydrogen, it's produced through methane gas pyrolysis. So there are companies today that are cracking methane and then using that energy to power an electrolyzer to produce hydrogen. And the final one is called brown hydrogen. That's made through ignition of black hole. So as you can see, there are multiple ways of producing hydrogen today. The only way for us to be successful and to reduce CO2 to zero is to produce hydrogen through renewable energy such as biomass or wind to get to the zero CO2 level. The KPMG Global Automotive Survey, which is an annual assessment of the current state and the future prospects of the worldwide automotive industry, in 2020, they talked to almost 900 executives from 43 countries. Nearly 80% believe that fuel cell vehicles will be the real breakthrough for electric mobility. This is why the automotive OEMs today are integrating fuel cells into their product lines. And most recently, you can see on the road, Hyundai, and Toyota offering clean transportation in our world. So in terms of, what's the best technology today? If you think about the challenges that the industry has, charging your battery-powered vehicle, it's 20 times slower than using a hydrogen charging vehicle. The convenience penalty for using electric vehicles can be represented as time spent charging the battery divided by the time spent using it for its intended purposes. The convenience penalty, what we call, is for a gasoline-powered vehicle, is about 0.5%. You can drive a mid-sized car about 16 hours for 5 minutes, for the 5 minutes it takes to fill it up. Battery electric vehicles have a much higher, what we call, convenience penalty. The best superchargers today have 100 kilowatt capability. That makes the convenience penalty for charging for a mid-sized car about 10%, which is 20 times higher than for a gasoline-powered car. The penalty is even higher for a large SUV, which is most prevalent today in North America. Most EV owners or battery electric car owners don't have access to superchargers. They charge their car at home or at work. For a 240 volt charger, the convenience penalty is 100%. For a 120 volt charger, it's about 1,000%. Hydrogen fuel cell vehicles provide zero emissions advantage over battery electric vehicles with the convenience and range of gasoline cars today. So in terms of powering and infrastructure, if you look at the infrastructure today on this chart, you can see what the comparison is of a battery-powered vehicle to a an electric vehicle to a hydrogen vehicle, right? In terms of real estate, it takes very little real estate for a hydrogen charging station for the grid that's required for electricity. And the CapEx for a hydrogen powering infrastructure is less than $5 million, where you need over $20 billion today for battery electric. So trends in clean energy. So basically, the fuel cell vehicles could be a real breakthrough from electric mobility, and mostly people agree to that. So considering hydrogen mobility needs, which direction would be moving in? So zero energy emissions. Hydrogen can be produced from unlimited sources, as I mentioned, and it has zero tailpipe emissions. So this is really the one way the world can get to zero CO2 emissions. Electricity stored as hydrogen provides a convenience of today's transportation fuels, right? Hydrogen refueling is much faster and more flexible than battery charging. But today, if you think about battery charging, we still all have range anxiety in terms of where are we going to charge our car, and is charging going to be available when we need it? And why should we have to wait versus our IC vehicle when we can fill our tank in less than 5 minutes? Still challenges that both the battery electric vehicle industry and the hydrogen industry have to overcome. Fuel cell vehicles can be developed at scale today. We see that in parts of the world where both Toyota and Hyundai and Honda have fuel cell vehicles on the road, and hydrogen is available. But if you look at that, you're still limited because hydrogen is only available in those locales where those cars are sold. There's no need to change current vehicle ownership model. We see that happening again with Honda and Toyota that are selling these cars through their current dealer network. It's convenient and it's safe, and you can refuel a hydrogen vehicle very quickly. So hydrogen adoption is rising, right? This is what we're seeing around the world today, right? Buses, delivery trucks, and forklift trucks constitute the first wave of deployments for fuel cell transportation. Fuel cell powered vehicles, electric vehicles, also have the potential for larger operating ranges, as well as refueling times that are significantly faster than the charging times for battery electric powered vehicles. With refueling times comparable to traditional diesel powered vehicles, this means that long refueling or recharging times do not need to be designed into the daily operating schedules of equipment fleets. So what we see today in the industry is there are now over 20,000 forklift trucks operating on what we call a battery box replacement, where the lithium-ion battery has been replaced with a hydrogen fuel cell. It's captive within a warehouse or within a port location where there's accessible hydrogen, and these are being used on a daily basis and emitting zero CO2. And again, automotive OEMs are introducing fuel cells in China, Japan, North Korea, and in the US. So Nuvera is building the hydrogen economy. So we're trying to bring innovation and value with a diversified portfolio of products. We're engaged with industry associations around the world to promote the clean use of hydrogen fuel cells. And then we're involved with codes and standards development. As you can imagine, with any chemical industry or any industry, codes and standards have to be developed over a period of time, and with the industry is working towards standardization of these types of things. Next, I want to move on to fuel cell theory and what is a fuel cell and how does it work. So fuel cell today is really, it's a branch of electrochemistry, right? The branch of chemistry that deals with the relationship between molecules. It's a chemical reaction that happens, and it includes a very number of disciplines, from chemical engineering to mechanical engineering to thermodynamics. So basically what happens in a fuel cell, you have a proton exchange membrane or a polymer membrane, and at Nuvera we call these fuel cell stacks. And we'll go into the details of what this involves. There are two types of fuel cells. The one is a proton exchange membrane that's based on a catalyst, platinum, and then a solid oxide fuel cell that operates at very high temperatures and is mostly used for stationary applications, so backup power for data centers. So fuel cell, what is a fuel cell? So the input is hydrogen, as we talked about. That's what's really driving the economy. So hydrogen and air are the inputs. The outputs are electricity, heat, and water. So the only byproduct of a hydrogen fuel cell is water in terms of vapor or water that's left on the ground while a fuel cell vehicle is in operation. So fuel cells come together under compression and pressure to increase the power output. So depending on the number of repeating components, which you can see on the right-hand side that you have, we make fuel cell stacks anywhere between 15 cells and 383 cells. That determines the amount of power that comes out of the cell. So the larger or the more number of repeating components, the higher the voltage. But that also creates reliability challenges, as you can imagine. So each cell consists of identical components. So a bipolar plate, a flow field, a gas diffusion layer for the hydrogen to diffuse through, a catalyst layer, and as I said, that is typically platinum, so fairly expensive, and a membrane. So each cell has three compartments: an anode, a cathode, and coolant. So these fuel cell stacks are put between two end plates. The purpose is to compress the fuel cell stack to allow the flow of hydrogen and air through the membrane. And these materials are typically aluminum and Teflon. So it provides rigidity and electrical and thermal insulation. And what you see on the right-hand side is a very short stack that generates about 5 kilowatts of energy. And as you can imagine, it is about 10 times as large to generate 60 to 80 kilowatts. So the purpose of each of the components, I think it's important to understand from a technical perspective how each of these work. Bipolar plates, it directs the flow of the reactions and the coolants to the respective departments within the fuel cell. These are typically made out of stainless steel, or they could be made out of carbon fiber. And they're typically corrosion resistant because you have coolant running through them, and they're sealed. Open flow field. This is to diffuse the gases or the reactive gases from when the hydrogen reacts with the platinum catalyst. And these are typically made out of nickel, chromium, and or graphite. And so the purpose is to maintain the permeability of the compressed stack under pressure, to avoid corrosion, and then to have low bulk and interfacial resistance. Fuel cell components, gas diffusion layer. This is an important component from the fact that it diffuses the reactants from the flow field to the catalyst, and it conducts the electrons off the catalyst to generate current. And these are typically made out of Teflon or carbon fiber, and they're used to prevent the puncture of the MEA. And then finally, the catalyst layer. The purpose of this is to facilitate the reaction between the anode and the cathode. And these are typically made out of platinum, carbon, or Teflon. So as you can see, many of the components that are used here are fairly expensive, and the typical cost of a hydrogen fuel cell in terms of dollars per kilowatt hour is in the range of $1,000 per kilowatt, all the way up to about $1,500 a kilowatt. So something that is a 10 kilowatt stack could cost $10,000, and if you're at 60 kilowatts, it could be almost $70,000 to $80,000. So this is a fairly expensive technology, which is one of the barriers that I think people have today with adopting the technology. And then the fuel cell membrane. The purpose is to conduct the proton from the anode to the cathode. It's also used to prevent the hydrogen and the air from mixing within the fuel cell components. And again, these are made up of Teflon and various other types of polymers. And they're used to prevent puncture and degradation. And then in terms of measurement, what's measured, the typical way of measuring a fuel cell stack is what we call a polarization curve, which shows the fuel cell output voltage over its entire range of current density. Our cells today are designed for between 0 amps per centimeter squared up to 2.5 centimeters squared. And there are three types of fuel cell losses. You get activation loss, ohmic losses, and mass transportation or current loss. And typically the efficiency of the fuel cell compared to a diesel engine. So a diesel engine is about 30 to 35% efficiency, which is the conversion of the amount of diesel that you put into the engine to the amount of power that you get out. And in a hydrogen fuel cell, you can get anywhere from 58 to 65% efficiency. So the conversion of hydrogen and is much higher in a hydrogen fuel cell than a diesel vehicle. And then power, fuel cell power and efficiency is measured over time. The highest efficiency operation occurs at lower currents, and the highest power occurs at medium to high currents. And then fuel cell stacks are designed to have maximum number of cells to get the maximum number of power. So I said the more number of repeating components or cells in the stack, the higher the power, but also the challenges of reliability and operability with the system. And then fuel cell stack aging, as you can imagine, because the fuel cell stack uses a catalyst, what happens over time, the catalyst is used, you have stack durability, so current density. As current density increases, the cell voltage decreases, and the power of the fuel cell will decrease over a period of time. And when I talk about time, that could be operable time of, after 4,000 or 5,000 hours. Most fuel cell stacks today are built to operate about 10,000 hours or more. So think of a fuel cell stack in a vehicle as a consumable, like your oil filter. After a period of time, because it's still emerging technology, you'll have to replace the fuel cell stack after 8 to 10,000 hours, depending on your operating conditions. And then moving forward in terms of what Nuvera does, So we make what we call a compact fuel cell engine. And this engine has unique controls, a compressor, the hydrogen input, and our unique technology is called open flow field technology. We're on our 8th generation stack technology. And the difference between Nuvera's technology and other technologies in the market is what we call free breathing, or in a conventional fuel cell, the molecules have to move in a defined path, where in the Nuvera fuel cell technology, it's open to generate higher power and higher electricity. In terms of cost of ownership, fuel cell-based vehicle solutions are also complex systems that require a sophisticated array of control, coding, and auxiliary equipment around actual fuel cells. If you think about your automotive engine today, that basically is running on software. So there are a lot of software systems that run the engine, and the same with the fuel cell system. You need software to run an engine. A hydrogen fuel cell cannot therefore be simply slotted into an existing battery vehicle. Much of the technology is still far from mass market adoption. So the maturity, reliability, and the performance of each component needs to be evaluated with particular care for mobile container handling machines and other applications. Finally, comprehensive industry standardization in the terms of hydrogen vehicle refueling is still in development. In terms of cost, what we see today as a benchmark, if a city bus costs $100,000, a battery-powered vehicle of the same size would be about $200,000, and the total cost of a hydrogen hybrid fuel cell bus would be about $300,000. So it's almost 3x the cost of a diesel-powered bus today. And that is the challenge that the industry continues to face. So it's the chicken and the egg. As the costs come down, as adoption increases, costs will come down for hydrogen fuel cell engines, and then adoption will increase over time. So Nuvera has a testing facility in Milan, and what we do today is we test engines and we certify engines here. Our engines have run an equivalent of over 1 million kilometers on the road in our testing. This gives the customer some confidence that the product will work. And then our design approach, our engines are designed for balancing power density and efficiency for long life performance. We make 2 products today. One is a 45 kilowatt engine and one is a 59 kilowatt engine. And I'll discuss some of the examples of where they're used and where they're operating today. And so it's a fine balance between the efficiency, the net engine efficiency, over the power that you get out of the engine. So if you think about the technology today, it is moving along a path of adoption. First, customers buy one hydrogen fuel cell engine to develop into a prototype vehicle that is typically run around the city for a period of time, and they look to generate a fleet after that. To make it successful for our customers, we provide applications development and customer support. So we provide training, we provide aftermarket service for parts and other things to bring the customer up to speed. So Nuvera provides a whole list of comprehensive customer solutions, from the technical support from when you contact us, warranty and support. So if you think about it, just like the diesel vehicle or the automotive market, our model mimics the service model of the automotive industry or the trucking industry to support vehicles in the field today. So from aftermarket service and parts to technical training to service centers around the world. So the big question is, where have hydrogen vehicles been adopted today? So as I said in the beginning, in the material handling industry, there's over 20,000 forklift trucks operating with various types of battery box hydrogen fuel cell engines. The bus market is a fairly mature market in places like China and in Europe, where there are over 2,000 hydrogen fuel cell buses operating today. India has about 3 hydrogen fuel cell buses that are in some degree or shape of being put on the road. And if you think about other applications for hydrogen fuel cells, delivery trucks, refrigerated box trucks, those are good examples whereby, though there's not infrastructure to drive long distances, most of these trucks or all of these trucks return to their home base at night. So if you think about a bus, it goes back to a depot, either to be charged today or refueled with hydrogen fuel cell. The other application is in stationary power, where this is used as a backup generator, where the hydrogen fuel cell charges the battery and can be recharged, as I said, in less than 10 minutes with hydrogen. And then mobile charging stations. Think about your battery electric car today. It becomes stranded on the road. They send out a mobile charger. That mobile charger has only a battery. It has to go back and be recharged. But if that has a hydrogen fuel cell on board, again, it takes 5 minutes to recharge and can be out of the road fairly quickly. We have robust manufacturing. So in terms of the technology today, one of the questions we get is, can we make hydrogen fuel cell products and can we deliver them to our customers? The answer to that is yes. We have a factory in Boston that can make 2,000 hydrogen fuel cell engines on an annual basis, and we're ISO certified. So the technology has advanced to the point of where it's commercial today. Not only us, but several of our competitors and other companies around the world are producing product and going into vehicles as we speak. Fuel cell stacks are made automatically. As you can imagine, it requires a clean room to be able to do this, and we have a machine that produces fuel cell stacks automatically. And then finally, to wrap up, there have been decades of research and development that have been done in terms of hydrogen and hydrogen fuel cell. The time is now where it's being adopted around the world. We can see adoption moving very quickly in China. We can see adoption moving very quickly in Europe, where the EU is building out hydrogen infrastructure in the EU countries. We can see in India, Energy Week this week, where Prime Minister Modi declared India will become the world leader in hydrogen. And there is a lot of energy, both from the public sector and from the private sector, billions of dollars that are being spent on infrastructure and driving demand. And then in the US, we see that it's much slower. We are behind the rest of the world, but soon to catch up. So at Nuvera, our motto is let's move the world together. Thank you.
Oh, thank you very much, Kedar. It's a really very informative presentation. Very useful and a lot of learning about hydrogen fuel cells. Okay, let's take a few questions from the audience. I have a few questions already. Let me put on the screen. Guys, if you have any questions, you can post your questions in the question box and we can address them now. Here we go.
So are there regulations in the world forcing companies to adopt zero CO2? The answer to that question at a very high level is yes. More specifically, in places like California. California back in 2014 said that no new diesel vehicles could be over a certain weight limit could be sold in the state after 2025. Several of the ports in California have declared that they will no longer allow diesel vehicles to operate in their vicinity in the ports after 2030. One of the biggest regulations is Fit 55 in Europe, where by 2035 you will not be allowed to sell a diesel vehicle in the EU. This goes both for automotive and for diesel. In other parts of the world, you're seeing a different way. In China, The government is building infrastructure to drive adoption. And then in the US, outside of California, the rest of the states are mostly wait and see. But in the end, it's really being driven by some of the global governments. So the best applications for hydrogen in vehicles. These are, I would say, if you think about the vehicles on the road today, the best ones would be for long distance trucking. So what happens today, if you take a 20-ton truck that's going to drive across Europe or across the US today, there are weight limits of 40,000 pounds. To be able to use that vehicle with a battery, you would take up almost half of the payload with the battery, and so it would reduce your payload significantly. If you replace the battery with a hybrid hydrogen battery solution, you'll be allowed to carry the same payload and you'll have the ability to refuel that truck in 10 to 15 minutes versus several hours with batteries. So today, the best applications are vehicles that return to base until the infrastructure is built up broadly and widely. It'll be good for non-automotive applications, so trucking and off-the-road industrial vehicles will be the best applications. So what progress has been made around the world? This is a great question. If I go back to what I said earlier, there have been significant advances in the material handling industry. So for forklift trucks, buses the technology is commercial in the bus market. Companies have over, in Europe, there's over 600 buses operating on a hydrogen fuel cell today. Again, these buses return to base, they're not intercity buses. So those are the two areas where progress have been made. But what you're starting to see is you're seeing a lot of government-supported projects and private projects around the world. So for example, in the Port of Los Angeles, Hyster-Yale has a container handler that's operating on hydrogen. In China, there's several delivery trucks that are operating on hydrogen. So progress is being made. And in India, there are a couple of buses that will be operational on hydrogen. There's a company by the name of H2E Power that has worked with EcoBus and Nuvera Fuel Cell, debuted a bus at Energy Week this week with that bus running on hydrogen. So the barriers. This is very similar to the battery electric. The barriers to hydrogen are obviously the infrastructure. Infrastructure needs to be built out around the world. It needs to be expanded from cluster infrastructure, which is located in a specific geography that caters to the return to home vehicles, to cross-country infrastructure. The second barrier is cost. The cost of hydrogen today is about $1 per kilogram made through steam methane reformation. If we look at the next generation of making hydrogen through electrolysis, it's almost $4 a kilogram. And if we look through blue hydrogen, which is making hydrogen through renewable energy sources, it's almost $6. Sorry, it's almost $8 a kilogram. So the cost needs to come down over time to drive adoption. The total cost of the fuel cell technology also has to come down. So where is India going? As I had mentioned, about 18 months ago, the government of India declared that they want to be the global leader in the hydrogen economy. And what you have seen since then has been a significant amount of influence and publicity from both the public and the private sectors. The companies like Reliance have declared that they're going to spend billions of dollars on infrastructure and driving demand. The government of India is now focused on vehicles, state-owned and government vehicles such as buses and trucks for decarbonization. And so there's a lot of energy and a lot of momentum in terms of the hydrogen economy. Just this week at the India Energy Conference, The Prime Minister again declared his vision for India. And my belief is that will happen over time. You see a lot of energy and a lot of companies getting involved in wanting to do something good for the country. So how do you see changes in the automotive parts, rubber, plastic, and metal parts industry if hydrogen energy gets accepted significantly? I think what you're going to start to see specifically in the industrial, call it chemicals or rubber industry, is that the people that are making these products today are going to start to ask for inputs that are made through more renewable energy and renewable sources. So as we know, the derivatives or the inputs for both plastic and rubber are made from petroleum-derived products. And what you see today is there's a big push for sustainable types of materials. And what you'll see is you'll see a pushback from the industry to the petroleum companies and to the gas companies to start to provide inputs that are sustainable. Any other questions? Can you talk on safety of fuel cells? Okay. So I think one of the key critical components is that people ask, is hydrogen safe and are fuel cells safe? The answer to that question is yes. A lot of hydrogen has been used in industry for over 50 years today. Hydrogen is transported across the road and is used in pipelines. And hydrogen cars are on the road today, and there have not been any issues with those types of vehicles that have been sold by Honda or Toyota. And in terms of the fuel cell, we have spent a lot of time in terms of safety and training of our products with the customers. So yes, they are safe. They're being used today in public vehicles. You can ride buses that are powered by hydrogen fuel cells, and you can drive forklift trucks and terminal tractors, all powered by hydrogen with hydrogen storage on board. Is it possible to integrate fuel cells into two-wheelers? The answer to that question is yes, you can do that. But today the cost is prohibitive in my mind. Two-wheelers would be a vehicle that typically return to base, return to home, they're driven to work, they come back. So much better technology for a two-wheeler is really still battery. And what you're starting to see in places like India are you're starting to see battery swap stations around places in Bangalore where the two-wheeler can stop, swap out a fully charged battery and go on their way. Hydrogen fuel cell technology is too expensive for that type of vehicle. So which market is growing in the world? The market is really being driven by Europe today. Europe is the leader in hydrogen fuel cell technology and adoption, followed by China, mostly driven by the government. But it would not surprise me if India starts to pull ahead over the next 5 to 7 years. What kind of materials are used in fuel cell stacks? I think I covered that in my presentation. Mostly its components like stainless steel, carbon fiber, catalysts such as platinum are used today, aluminum, and other polymers.
Thank you, Kedar. That's all the questions we have. Thank you very much. Really
Thank you.
Very informative presentation. Before I end this session, I would like to give final remarks to the audience, please.
Thank you very much. Yes, thank you very much. I think this is a very exciting technology that's going to continue to deliver over time. The hydrogen economy is now, as you can see, it's being driven by a lot of public and private interests around the world. And it's very exciting in terms of something that's very new and emerging in the world today.
Thank you very much, Kedar, for being part of this advanced technology news server, for accepting my invitation and putting together a nice presentation today. Appreciate that contribution.
Thank you very
I
much.
hope to see you in the future sessions. Yeah? Thank you very much.
Thank you. Have a good day. Bye-bye.
Guys, that's the end of this session on the latest trends in hydrogen energy economy by Mr. Kedar Murthy. He's the Chief Commercial Officer at Nuvera Fuel Cells based in USA. I believe that this presentation is really useful and very informative to all of you. And if you have any questions or anything, that you can always reach out to Kedar Murthy, the Nuvera. So I'm going to end this session here today. I'm hoping it's really useful to you. I see you in the next episode of the Advanced Technology News Server. If you have any comments, suggestions, I welcome you all, and please join the journey of the technologies. Thank you all. Bye for now.